Welcome. Let's try to solve another Leetcode problem. 239 sliding window maximum. For this problem, we are giving integer nums, and we are also giving an integer k. So k is the size of the sliding window, which is moving from the very left of the array to the right. So this means we can say key numbers inside of the window. So for example, this is our first window, so the maximum number is going to be 3, and then we're going to shift to the next window. Yeah, so the maximum number is going to be 3 as well, and we're going to shift, it's going to be 5, 5, 6, and 7. Each time the sliding window moves right by 1 position, so we're going to return the max sliding window. So this is going to be, we're going to return an array. So inside of the array, it's going to be the maximum number inside of the sliding window. So this is a 3, and this is another 3. Normally, if we are going to solve the maximum sliding window problem, we're going to use the monotonic queue. Yeah, because it is a sliding window. So let me just make a drawing. So this is a sliding window. We're gonna slide, and inside of the sliding window, we're gonna choose the maximum number. So currently, we need to decide whether we're gonna use the monotonic increasing queue or decreasing queue. Because we are going to check the maximum number. Normally for this problem, we're gonna check the first number inside of the queue. Yeah, so this means we're going to use the monotonic decreasing queue to solve the problem. So for example, if the number is like 3, 2, and 1, if it is monotonic decreasing queue, the size is going to be 3, so inside of the queue, it's going to be 3, 2, and 1. And this number 3 is going to be the maximum number, and we can choose this maximum number. But for another example, so maybe the number is maybe 2, 3, and 1. So if it is a monotonic decreasing queue, first number it is a 2, the next number 3 is bigger than 2, so we're gonna pop out the 2, so we're gonna append 3, and then it's gonna be 1. Yeah, so inside the sliding window, the first number gonna be the maximum number 3. Yeah, so this means for this problem, we're gonna use the monotonic decreasing queue to solve the problem. Yeah, so if the number is like 1, 2, 3, so inside of the queue gonna 1, gonna pop out, 2 gonna pop out, and then it's gonna be 3. So at the head of the queue, it's gonna be the maximum number. Yeah. But what if it is a monotonic increasing queue? So if it is monotonic increasing queue, for this number 3 to 1, let's just check. First of all, this number gonna be 3. Next, 2 is smaller than 3, we're gonna pop out 3, and we're gonna have a 2. 1 is smaller than 2, we're gonna pop out 2, then we're gonna have 1. But inside of the queue, how can we find the maximum number? Because the maximum number is 3. Currently, it is 1. So this means we cannot find it. If we are going to check the maximum number, it's going to always be the monotonic decreasing queue. At the head of the queue, it's going to be the maximum number. So if we are going to solve a sliding window minimum number, so it's going to be monotonic increasing queue. At the head of the queue, it's going to always be the smallest number. Yeah. Now we just need to use monotonic decreasing queue to solve the problem. Yeah. So we're going to use the data structure queue from the Python. So from collections, we're gonna import this double-added queue. Now we can use it directly. Let's just use a queue, and so q gonna equal to the queue, and let's just prepare the final result. So the result gonna be empty array. Yeah. So for Rn in enumerate, so we're gonna enumerate the nums. We're gonna use a while loop to check. So while q exists and the count number. So normally it's gonna be smaller than the number at the tail of the queue, but if it is bigger, nums q minus 1 at the tail, so we're gonna pop it out. Yeah. after that, we need to put the index inside the queue. Yeah. So the condition is that we need to check the sliding window. Yeah, the sliding window currently is equal to k. If it is bigger than k, we need to pop it out from the head because the window size is too big. We need to pop it out at the head of the queue. So we need to have a check while r minus q0 at the left side plus 1. If it is bigger than k, we need to pop it out from the left side. Now we need to put the number, the maximum number, inside the result. Yeah. So the condition is that if r more than or equal to k minus 1. So for this example, k equal to 3. So for the index, if it is at the 2, index 2, definitely we're gonna append the maximum number inside of the result. So currently we're gonna append this number, so it's gonna be nums q0. Finally, we need to return the final result. Now let me just run it to check if it works. Yeah, maybe it doesn't work, but let's just have a check. Result, I didn't prepare the result. It's gonna be an empty array, right? Yeah, as you can see, it works. Now let me just submit it to check if it can pass for all testing cases. Yeah, as you can see, it passed for all testing cases and it's pretty fast, and the time complexity is on. So this is why we're gonna use the monotonic queue to solve the problem, because we just reduce the problem from on squared to on. Before it is n times k, now it becomes on. Even though here is a while loop, so here for each of the for each of the for loop, we check one number. We just check one number, and if there's some number inside of the queue, so we're gonna pop it out. If there's some number inside of the queue, we're gonna pop out. But how many operations? So in total, there are gonna be only on operations. So the time complexity is gonna be on. I think that's all for it. Thanks for watching.